litmus test. So we take the blue litmus paper and dip it in carboxylic acid. Blue litmus paper changes to red litmus. So when blue litmus converting to red litmus, we can say it is acidic compound. We cannot say carboxylic acid, but we can say acidic compound. So it is only useful whether the compound is acidic or basic. Second one is sodium bicarbonate test. When carboxylic acid treated with sodium bicarbonate, acid base reaction takes place. H plus and HCO3 minus, corresponding acid base reaction takes place. Carboxylic salt plus H2CO3 will be formed. Now H2CO3 decomposes to CO2 plus water. CO2 plus water. So it gives effervescence of bubbles of CO2. That means all carboxylic acids give effervescence of CO2 with sodium bicarbonate. Here H2CO3 is weak acid, carboxylic acid is strong acid, weak acid corresponding conjugate base strong base, strong acid corresponding conjugate base weak base. So strong plus strong reacting giving weak plus weak. That's why the reaction is progressing. Next test is ester test. Ester test. When carboxylic acid treated with alcohol in the presence of H plus, Fischer esterification takes place. Fischer esterification takes place. So corresponding ester will form, and generally carboxylic esters have fruity smell. Carboxylic esters have fruity smell or sweet smell. The sweet smell indicates the compound can be acid or alcohol. Next, test for formic acid, especially for formic acid. When formic acid treated with Tollens reagent, so Tollens reagent mainly having Ag plus and OH minus. Formic acid undergo oxidation, CO2, and CO2 will be converted into CO3 minus 2 in basic medium, and silver will be reduced to corresponding silver. Silver ion will be reduced to corresponding silver. It is also called silver mirror test. Silver mirror test, and also called Tollens test. Formic acid when treated with Fehling solution, formic acid undergo oxidation, form CO2, and CO2 in the presence of basic medium converts into carbonate. Fehling solution mainly contains CO2 and OH minus. So Cu plus 2 plus OH minus, and Cu plus 2 will be reduced to Cu2O, and which is a red PPT, and red PPT conforms the corresponding carboxylic acid. It is a only carboxylic acid which is oxidizing by tolerance and failing. When formic acid treated with mercury chloride, formic acid undergo oxidation and mercury chloride undergo reduction and form mercurous chloride. So it is a completely balanced equation. Formic acid reacts with mercury chloride and form mercurous chloride, and this mercurous chloride is white PPT. And other carboxylic acids do not react with mercury chloride. Other carboxylic acids cannot be oxidized with mercury chloride. Formic acid also oxidized by bromine in water. That means we say formic acid decolorizes bromine water. So here bromine undergo reduction and formic acid undergo oxidation. Bromine undergo reduction and formic acid undergo oxidation. Therefore formic acid decolorizes bromine water. So formic acid can give tolerance test, failing test, and white PPT with mercury chloride and decolorizes bromine water. So 4 tests are positive, and other carboxylic acids do not give any test. So it is a difference between formic acid and other carboxylic acids.